Now we start to introduce the library of the Hadoop MapReduce. We will try to download an example, then we can know the procedure of the Hadoop or MapReduce. In this course, we will implement the Hadoop or MapReduce environment. The Hadoop and the MapReduce environment is based on the Java programming language. So we have to install the Java environment first. Of course, when you already complete install your cloud operation system or the cloud environment, please update your Linux environment from the internet. Then download or install the Java package from the internet. However, corresponding to your version of the Ubuntu cloud environment, you have to install or configure the corresponding Java package, maybe from some company, or you need to download the Open Java package from the internet. Of course, if you want to update your cloud environment, you have to do the updating first. No matter you use the Ubuntu desktop or the Ubuntu Enterprise Cloud, you need to add the source file for package updating in the terminal environment or in the graphical user interface environment. You need to give the command. If you use the Ubuntu desktop, you can use the gedit firmware for editing the source.list file. Otherwise, if you use the Ubuntu Enterprise Cloud, you need to use the VI editor to rewrite the source.list file under the path etc apt. Then you have to change all the paths or replace the path from the tw.archive.com to ubuntu.stu.edu.tw. Then you can update the package to the current version. It costs the time for updating based on the internet. Be patient. You may need to spend about 20 minutes to 30 minutes. Depends on your physical computer and the speed of the internet. After updating your environment, then you can try to get the Java. Here are the terminal command to obtain the Java package. However, it depends on your Ubuntu version. If you use the current version of the Ubuntu Enterprise Cloud, some command or parameters should be changed. When we do the laboratory exercise, the teaching assistant will tell you which kind of the Java should be downloaded to your Ubuntu Enterprise Cloud environment. For example, different Ubuntu Enterprise Cloud environment will have to install different Java packages. The above is the Sun Java installation. You have to get and install the Sun Java SDK into your Ubuntu Enterprise Cloud. Another version of the Ubuntu Enterprise Cloud may be need to download the Open Java package. However, no matter you use the Sun Java or Open Java package, be sure that the Java version should be 6 or newest. Then, the Java can support the Hadoop or MapReduce API. Otherwise, your MapReduce or Hadoop example cannot be compiled and executed. So you can confirm your Java version after you install your Java package. By use the command java space dash version, the Open Java package will be version 6 or above. If you use the Sun Java, then you should be obtain the Java version 1.6 above. Then you can establish the correct Java environment. In addition to Java environment, we need to configure the connection between the client user and the server. So we have to configure and install the SSH connection and the resync connection. We need to get and install these two connection packages because Hadoop will use different connection between different machines. After installing and configuration of the Java environment and the connection package, now we can install the Hadoop package. Suppose you use the Ubuntu Enterprise Cloud environment, then you only have the terminal environment for you to execute the command. Please first change to the OPT path. You have to change the correct portfolio or the correct path. Then you can download the Hadoop package. Now the Hadoop package version will be newer. Of course, during the exercise, the teaching assistant will tell you the recommend or remodified command for download the correct Hadoop package. This Hadoop package will be downloaded and saved as a file under the path /opt and unzip your package. Rename the original name of the document or the portfolio to the Hadoop. Of course, we cannot provide the account administrator to the client user, so we need to configure the group and the user account. First, we will create a group for the Hadoop exercise. So we will need to add a group, and the group name will be Hadoop. Then we will create a user account. The account name will be Hadoop and belongs to a Hadoop group. However, we need to change the owner or authority of the original group and the document. So we will change the owner or the authority of the user Hadoop to control and manage the document. Since the Hadoop or MapReduce procedure will output some temporary file, no matter the MapReduce result or the final report. So we have to create a Hadoop output temporary storage space for the Hadoop or MapReduce procedure. The first, we need to create a new space. A new storage space for the temporary file or information. So we will try to make a new document in our Ubuntu Enterprise Cloud. Of course, we have to change the authority or owner to the Hadoop group and the user account Hadoop. Then we can use this new temporary storage space. Since you already configured the Java environment, connection environment, and the Hadoop environment, you can try to do some exercise. The first, you need to change to the Hadoop account. Switch to the Hadoop account user, then you can emulate the client user to do the commands for the Hadoop or MapReduce exercise. The first, you need to configure the Hadoop environment. We need to configure the Java home parameters, Hadoop home parameters, and Hadoop configure direction. So you need to add the Hadoop environment.sh to add the new parameter path. Of course, if you use different Java programming language package, you need to configure your path correctly. Not only the Hadoop environment should be added, but also other three XML files should be reconfigured and modified. The first, we need to configure the core site.xml file. We need to tell our Hadoop where is the Hadoop distributed file system. Of course, originally the Hadoop can be provided to the remote client user. So most of the connection and if information is changing will based on the internet. However, today we do the exercise in a single physical computer. So the Hadoop distributed file system will be located at the local host, and the connect port will be 9000. And we will use the temporary path hadoop.tmp temp.direction, and the value will be given as the Hadoop path, and add the user name. You can add this parameter as your Hadoop account. Then you can completely modify the code site XML. The second, you have to modify the Hadoop distributed file system site.xml file. You need to add the configuration parameters. The name will be distributed file system and replication. The value will be 1. Of course, there are different values and indicates different functions. Due to our exercise, we only need to set up 1. If you want to know more, we suggest you can check the value means by the website. The last one, you need to modify the MapReduce site.xml file. We will need to reply the execution result from different task tracker. Of course, all the communication and data transmission will be based on the internet. Hence, we need to assign the MapReduce job and the tracker. The value will be localhost. The port will be used 901. Then, the name node and the data node, or the job tracker and the task tracker will know how to communication between each other. Finally, change to the Hadoop path you create before. You can format the name node first because we need to storage the big data. So you need to use the command Hadoop name node /format to create a clean name node. After you create a name node, it means the Ubuntu Enterprise Cloud already prepared to receive the big data for the further execution. Hence, now we can start or activate the Hadoop service, start all the sh command in the terminal environment. You will find many compiled results. You can know the Hadoop service is established or not by use the command JPS. Then you will know the name node, the data node, the task tracker, job tracker. Sometimes we may have the secondary name node and JPS. These 6 services of the Hadoop or MapReduce should be established and implemented. If you do not have these 6 services, please stop all the service and retry again. You have to find which service is lost. Only these 6 services are established, then you can do the further Hadoop exercise. Now we will try to do the Hadoop or MapReduce example. The first, please download the Hadoop example file. You can get the example file from NCHC. This is a basic big data Hadoop MapReduce example. This example is implemented to count the words in the sentence or in the articles. After you download the Hadoop example file, please test the file if you are already downloading the Hadoop completely. Then we can execute the word count example. Of course, since the Hadoop portfolio or document is owned by the Hadoop group and the Hadoop user account, please switch to the correct account. Then you can make the new temporary input portfolio. You can use the simple sentence or upload the data file to the Ubuntu Enterprise Cloud Hadoop path. Then we will require the Hadoop environment file system to put our input sentence or upload data files into the file system. You can check the state or the situation of your uploading data file or your sentence in your input path. Then now we can use command to get the word count.java. Of course, we need to compile this Java file based on the Java and the Hadoop package. Then we can execute the word count.jar to execute the word count example. And the word count example will obtain the data in the input path, no matter the uploading data file or the sentence you write in the path. And the result will be sent to the output path you configured. Of course, the job tracker will try to collect all the task tracker results from the task tracker. So different parts will be obtained from different task tracker. You will find it spends a lot of time because the MapReduce should do the map job, divided all the original data file or the sentence into several partitions to different task tracker. Then the system, even in a single physical computer, will try to emulate the network, so the job tracker will send this divided sentence or data file into different task tracker. It causes the time delayed. And after the execution in each task tracker, the result should be replied to the job tracker. Again, we need to spend the time delay to collect all the results. Not only the map procedure, but also the reduced procedure will do the same thing. So we will spend a lot of time in data transmission based on the network. And since we use the Ubuntu Enterprise Cloud to provide the service to the remote client user, the remote client user should use the web user interface to know the situation. So if you have the valid IP address, you can directly provide the service to other client users based on the network. So if you want to use the web user interface, you can use the local host. The connection port will be 5030. Then you can find the Hadoop management interface or the 560 to know the Hadoop task tracker state. Of course, you can also find the Hadoop distributed file system state or the situation. Here is our example. You can directly type the sentence into the input data or as the input data for our Hadoop MapReduce system. Today, we use the sentence, I am a student. You are also a student. Then the Hadoop MapReduce procedure will be created and sent to the welcome example or the welcome procedure. The welcome procedure will map the original whole sentence, for example, to 3 tasks. One job tracker will send these 3 tasks to 3 task tracker, or we say map to 3 task tracker. In this case, I am a will be divided 1 task. Student, you are, will be sent to the second task tracker, and also a student will be mapped to the third task tracker. So each task tracker will try to count the word and the times of the word appear in the task. So each word or vocabulary will be the key value. For example, in the first task tracker, I am a. It means the first one key value will be I. The second key value will be am. The third key value will be a. And these 3 key values only appear once individually in this task. So after counting, these 3 task tracker will send their report to the job tracker. So the job tracker will collect all the reports from 3 task tracker. Then this welcome procedure will try to reduce the report. So in this case, there are originally 9 key values replied from 3 task tracker. Then the welcome procedure will reduce this report as 1 job, then reduce to 2 tasks. Try to low balance. So the first task will include 5 key values. The second one will be 4 key values. So the first task tracker, to reduce the original report, will merge all the results. So the same key value will be merged as one result. For example, there are two key values the same from different map task tracker. Now these two key values, although they appear once individually, now reduced to the repo will be twice. This key value will appear twice. And for example, also, this vocabulary only appear once. Even after merge, we only obtain once appears in the original sentence, so we will obtain or get a result with the key value also, and the value will be 1. In the second reduced task tracker, for example, student, in the original report, job will be job key value student once, and job student once. They appear 2 times. And after merge or reduce task, these two same key value student will merge their appearing times. So in reduced task 2, we find the key value student will be with the value 2. Finally, these two reduced task tracker will send the report to the job tracker. So the completely report will be replied to the remote client user. Each value or words will be set as the key value with the appear times as the value. So the remote client user will know how many times of one vocabulary or one word appear in their sentence.